Okay, let's take a look at the next part of the brain. The next part of the brain is the cerebellum, and it is down here on the bottom and in the back. Take it off. And you can see it's a very small percentage of the whole brain. However, it has more neurons in it than all of this part up here. The word cerebellum means little brain. It is responsible for coordinating muscle movement. Now, that might not sound like too much of a big deal to you, but just look at the movement that would be required for you to take a few steps. If you want to just take a step forward, then you have to contract the spinal muscles on one side and all of the muscles of your leg so that this side of your body will support all of your weight. Then you need to contract the muscles on the front of your other thigh. At the same time, you relax the muscles on the back of that thigh so that you can pick that foot up. Then you need to extend that foot. And as it comes down, you need to tighten all of the muscles in that leg so that it can now support the weight of that body, of your body. Then you need to relax your spinal muscles on one side and contract them on the other. And you're kind of getting the idea. And that is just to step, not even including swinging your arms. And if you want to do some sort of a dance move with the magic fingers, man, think of all the different muscles that have to move. And every time you contract one muscle, you need to relax the opposite muscle. So where I have a muscle that pulls my finger that way, I've got another one that pulls it that way. I don't want them to contract at the same time, otherwise I'll just convulse. So if I'm going to go this way, I need the muscles on top to relax. Your cerebellum is what coordinates all of that. And there's a grooving in process. And if you've ever watched a baby trying to learn to walk, you can see that your cerebellum has to learn what muscles to contract and relax in order to get the desired effect. This is also the center for your rhythm or lack thereof. I'm a percussionist and I have a drum set, and I have noticed that you can put somebody down at a drum set that's never really played before, and you can tell pretty quickly if they've got an innate sense of rhythm. You can do it as well by watching somebody dance. for, for example, some people, bless their hearts, have no sense of rhythm. I'm not sure if it's trainable or not, but I know that innately some babies just have a sense of rhythm. You can watch newborn babies when you play music. Some of them just rock. They get that groove pretty fast. This is also the center for muscle memory. All athletes know about muscle memory. And by the way, just as a aside on that, practice does not make perfect. Only perfect practice makes perfect. You can groove in something into muscle memory that is totally wrong. A fine example would be my golf swing, which is abysmal. I can crush it, but I'm never sure exactly where it's going to go within a certain arc in front of me. It's just one of those things that I never grooved in. On the other hand, I can throw a football or something like that. That's going to go where I want it to go. I used to also swim, and that is a combination of rhythm and muscle memory, where you have a timing of when you breathe, and also a relax. Those of you that have jogged before with any degree of regularity know that when you first start running, you can't get your breath. You're out of rhythm. You don't really have any good timing, and then the more you do it, you kind of develop this natural in and out rhythm. Mine was in 2 3 out 2 3 in 2 3 out 2 3, with the 2 3 being the steps. It's just the natural breathing rhythm that is what works for me, and it grooved into my muscle memory back when, way back in high school, when I ran cross country. Don't ask me why. Anyway, that's the cerebellum. Now, the top part of your brain is the really interesting part. That's the cerebrum. That's your conscious brain. Everything that we've been talking about up until now has nothing to do with what you're aware of or who you are, but the cerebrum does. And even more interesting, it's a very, very thin band in the very top part of the cerebrum called the cerebral cortex, in which all of that information is located. Now, you might notice that the cerebrum is very, very wrinkled. It's wrinkled for a reason. It increases the surface area. As a matter of fact, it triples the surface area. All of those convolutions, by the way, the little humps are called a gyrus, plural would be gyri, and the little grooves in here are called the sulcus, plural would be sulci. And then there's a little band of gray matter right below that. That gray matter is only 1/8 of an inch thick. It's only got 6 cell layers in depth. But that little band, 1/8 of an inch thick, is everything that you are. All of your personality is right there in that little band. And it's all located up here in the front. And we'll come back to that in a second. What most of the cerebrum is this white matter underneath. But this white matter is just connecting tracks, connecting different parts of the cerebrum to each other. Also note that the gray and white matter are opposite in the brain as they are in the spinal cord. In the spinal cord, the gray matter's on the inside and the white matter's on the outside. In the brain, the gray matter's on the outside and the white matter's on the inside. The white matter, remember, is axons that are myelinated. So that's where you're moving information along a distance. The gray matter is just where you've got tons and tons of cell bodies all crunched together. How much? Well, if you took a little piece of the cortex the size of a grain of sand, just the size of a grain of sand, it would have 100,000 neurons and 1 billion synapses. Each neuron can synapse with up to 40,000 different other neurons. So if you take the number of neurons in the cerebral cortex, which is about 16 billion or so, roughly, and you multiply out all of those possible synapses, then you come up with more possible routes than there are stars in the universe, which is really, really impressive. It so happens that men have 52% more gray matter and slightly larger brains. But before you guys get too excited about that, there are no statistical differences in intelligence between males and females. So I guess the ladies could have a case that we've got more and do less with it, maybe. However, women have 10 times more white matter. That means they have more interconnection in the brain. This certainly plays a part in the fact that women are more likely to be able to recover from a stroke than are men. The right side and left side of the brain are split and only connected by a part called the corpus callosum. And that is much more highly interconnected in women than in men, and we'll come back to that in the next lecture. Here's the location of the cerebellum here, and here's the cerebrum. So this would be the ventral surface, the front, and this would be the dorsal surface, the back. And up here in the frontal lobe, that's where your personality is. That is what makes you, you. It's where you do your judgment. That's where you decide if how you feel about things, what you're going to do, what course of action you're going to take. It's your planning center, your concentration center, and where you decide to express your emotions. Your emotions are generated deeper in the brain, but then they come up to the cerebral cortex, and you get conscious control of how you're going to express that. It is not developed until the mid-20s. Isn't that interesting? And, as I'm sure the ladies would agree, it matures 3 to 6 years earlier in females than it does in males. So, there is a reason why, by the way, the United States Constitution does not allow you to run for president until you're 35. I don't know if you guys know that that's a constitutional prohibition, but there is actually an age limit. We can't have a teenage president or something like that, or even one in their 20s. It is prohibited. And that is actually, it turns out, although our forefathers could not have possibly known this, a very wise thing to do, because your ability to uh, judge things and your ability to concentrate are not even fully developed until your mid 20s. So to say that then you're therefore going to just run the country when you yourself have not finished developing would be a very poor idea. I think their idea was more along the lines of experience and wisdom, but it just so happened to work out into neuroanatomy as well.